All right, short and sweet for 6.5, we're going through average value of a function. We've got the mean value theorem for integrals here. If f is continuous on a closed interval a to b, then there exists a number c in ab such that f of c is the average value is equal to 1 over b minus a times the integral from a to b of f of x dx. That is, integral from a to b f of x dx is equal to f of c times b minus a. So f of c some height, b minus a the length of the base. So we're creating a rectangle that would have the same area as the integral over that interval. All right, so note here in the mean value theorem for integrals, the value f of c is called the average value of f on the interval a to b. So we'll try one and then take it a step further to find the value c like we did for mean value theorem for derivatives as well. So we'll find the average value of f of x equals 3x squared minus 2x on the interval 1 to 4. So that's our a and b. So our average value, f of c, is 1 over 4 minus 1 times our integral from 1 to 4 of 3x squared minus 2x dx. The 1 over 4 minus 1 is just a 1/3. If we take our antiderivative, nice easy polynomial, right? Continuous everywhere, so mean value theorem applies here. We get the x cubed minus x squared from 1 to 4. And then just simplify. We've got a 1/3 times 4 cubed minus 4 squared minus, summing the 1 in for both will give us a 0, but 1 cubed minus 1 squared. Gives us a 1/3 times 64 minus 16 minus 0, or a 1/3 times 48, which is 16. All right, for 2 again, we'll find that average value, and then we'll find the number c such that that is the average value, right? F of c gives us the average value. So we're finding the average value of f of x equals 1 over x on the interval 1 to 3, so it's our a and our b again. 1 over x, discontinuous at 0, but continuous on our interval, so we can find this value. So f of c here equals 1 over 3 minus 1 times our integral from 1 to 3 of 1 over x dx, which gives us a 1/2 times the natural log of x, evaluated from 1 to 3. We've got all positive bounds, so we can drop the absolute. And we end up with a, thinking ahead, but a 1/2 times the natural log of 3 minus the natural log of 1, which is just 1/2 natural log of 3, or natural log of 3 over 2. All right, and so that is f of c. We also know that f of c is 1 over c. So we can set these two equal to each other and solve for c, or find c. So 1 over c is equal to the natural log of 3 over 2. Or we can cross multiply, right? 2 equals c times the natural log of 3, and then divide out our natural log of 3 to find that c is equal to 2 over the natural log of 3. All right, and we can draw a little picture down here just to see what's going on. Put in our curve for 1 over x. Just that positive side's fine. It's got the point at 1, 1. And we were taking our integral from 1 to 3. With that, 2 over ln 3 is about 1.8. So there's some point here in the middle that if we take as the height, would have the same area, right? This rectangle 2, right, for the base times 2 over ln 3 the height, which would give us the same as the area of the integral, right? The area under the curve. So that's it. 2 little things for the section. We'll focus more on all the other stuff when we review, but that's 6.5.